roll, please. A speeds and B speed. And speeding on both.
And go ahead and slate.
Imagine your desk in 1980, and imagine all the physical things that would be on your desk to do what your iPhone does today. You would have an atlas, you'd have a compass, you'd have a flashlight, you'd have a camera, you'd have a television. It's unbelievable the pile of physical stuff you would have on your desk. Now imagine the same thing for an automobile transportation system. That's the kind of transformation we're talking about.
In your own words, what is a software-defined vehicle?
It means a lot of things to a lot of different people.
The primary experience and function of the vehicle is driven through software.
The software is creating the experience.
A software-defined vehicle is a vehicle that can have features added to it.
You can change the definition of that vehicle at a moment's notice.
And you can change the way it responds or behaves in much the same way that your iPhone or your Android phone or your home PC can kind of change exactly what it's doing.
I think of a software-defined vehicle as a smartphone on wheels.
My smartphone is connected. My smartphone is intelligent.
Has a lot of sensors, a lot of software.
And my smartphone updates the operating system. My apps are customized to the data that they are collecting about me, and they're contextualizing everything for me.
Take one, soft sticks.
As consumers, we're not interested in buying something that is just going to never change. Instead, being able to buy a thing like a car and say, well, it's going to get better and better over time. And I don't have to replace it right away because I will get the things that really, for me, provide value.
And it allows you to do a software update that improves your whole fleet all at once. And if you can charge for upgrades because you're adding functionality, now you basically are monetizing it over a much larger number of vehicles.
Once you sell the physical car, what kind of conveniences can you provide to your customer?
It was a clear demand from the customers that the brand new Mercedes shouldn't just feel new when they got it directly from the dealer. It should be continuously be fresh and updated.
Your experience in a Toyota Lexus could be different than another person's based on how you want that experience to be.
Reimagining the car as really a platform where software can define the entire user experience.
We are just like your butler at the time. Oh, here's the seat, here's the steering wheel. Right? And here's your desired temperature, and here's the driving mode that you used previously. All of these are enabled by software, and you just think the vehicle is tailored for you.
With software and with software-defined vehicle, it's not only changing the product, but also fundamentally changing the business model of a one-time sale of a car.
Everybody's recognizing that if you don't take software seriously, you're going to get left behind.
Managing data is actually kind of boring. But what could be exciting is, can we take that data and turn it into the promise of what we were told as kids when we watched Knight Rider or the Jetsons, that our life was going to be better through technology?
Raj, take one, common mark.
We have the technology in forms of data analytics, but we have to be able to find some unique patterns in the behavior of the customer.
I mean, we want to use data off the vehicle to learn what people like and what they don't like and learn what we need to improve or not improve.
Because if you're in the vehicle, that's a great way to sense information about you, especially if you're in the vehicle every day. You can begin to learn chronic or long-term trends.
They can even probably find a pattern. Hey, some person is, say, braking 5 times within a certain second of certain G value, for example. A safety person can come in and say, oh, maybe the scenario is they're trying to avoid an object. You should look at these other factors of data, and they'll come up with a scenario. Oh, this is what probably happening. The recognition of unique patterns is where we're going to add the value.
Having access to that data coming out of the vehicle is critical, and then the ability to update every module, save none, in that vehicle is what I think set us apart so that we could shape it.
Tesla has shown that you put the same technology on a Model 3 as you do on a Model S, and that way you can gather huge amounts of data.
We couldn't have developed that car nearly as quickly if we didn't have all that data stored and access to it quickly.
10 years ago, the computing power we have in a watch or in the car took up much more space. You know, it was like putting a server in a car or something. You wouldn't do it, right? Today, modern cars use Ethernet. By putting Ethernet in the car, you get rid of bundles of wires and crazy amounts of weight and reliability. I mean, we're adopting not only the processing power of computers, but also the interconnects. 'X, and the way that the computers, talk to the world.
How do you extract data from a vehicle? How does the OEM monetize the data from the vehicle? And how does that provide a better experience for the driver?
One other significant decision we made that really helped was to put a cellular modem in the car and to be willing to move a lot of data over that connection.
If you look at the Internet of Things, you have to connect everything to the cloud in order to enable that software-defined experience.
Well, what we are doing is building a ship-to-cloud architecture and making everybody understand that the mission to do this is all about getting the connection to the customer.
When a device is connected and when a device becomes smart and intelligent, the customer expectations change completely.
We can talk software-defined vehicles, and that's really an exciting future. It's going to be software-defined life. And that's really where this is headed.
The idea of this software-defined vehicle is we don't even know what features will be created in the future. But the opportunity to customize it, the opportunity to add new features, the opportunity to add services, it's going to be orders of magnitude more than anything we've seen before.
When you open the car, what can we do with software to make you feel more welcome and recognized?
The cameras that we're using here right now could also face the driver, so you can actually start to connect the two together.
We organize that software into services and applications. Services are sort of your remote control into the hardware. And then the apps use the services to create different points of value. I could take a camera service and combine it with a door lock service and automatically set the child lock if the camera sees a kid in the backseat. Now you start to say, well, wait, we have this computing power in the vehicle. What else can we do with it?
For example, if you're a Jeep enthusiast but have never been off-roading, how do you first educate them on how to do off-roading? How do you put them on a beginner trail? And then an interesting twist to this would be like if there is an interior camera in the Jeep that they're driving and you notice that they don't have camping essentials or they don't even have water and they're going on a pretty long trail, you can ask them, hey, do you want me to order water for you and deliver it to your car based on your geo position?
You can add things you could never imagine. It also fix problems that you didn't think you could fix. We had hardware problems with shipping vehicles, and we'd figure out how to work around those hardware problems in software, push a software release out to the entire fleet of cars, and avoid customers ever dealing with whatever that hardware problem was.
We had a concept that if the door was locked, they're electric. The first pull would open the doors handles, the second pull would open the door. We saw that, frankly, customers were always pulling really hard and opening the door on the first try. They didn't like that feature. A month after we shipped the car, we shipped a software update that on the first pull, it opens the door. It's a small thing, but for those customers that were annoyed by the way it behaved, it was like magic.
One of the things that we're testing out right now is the ability to, if the driver opts in to share their driving patterns, is for us to then make recommendations on what would be the best vehicle for them. And where this comes into play is on a battery electric vehicle, where if people want to know which of these battery electric vehicles are best for me, or is it a hybrid vehicle, we can look at their driving patterns and say, based on how you drive, this would be the most economical or the best type of vehicle based on how you drive.
How does that culture of this love for vehicles and customizing them, how does that continue in this software-defined world?
It still has to be a beautiful design. It still has to have great, exciting performance. Drivability, the handling, the sound, that type of stuff is all very important.
We think there's lots of enthusiasts out there that want to have unique experiences. Let's say that you want to have the car tuned in a way of your favorite driver who drove on the Nürburgring. We can download that experience to the vehicle and have the tightness and the acceleration all tuned based on how that driver wants it. That would take more processing power in the vehicle, and that would take some more storage needed on the vehicle. But we are looking at those opportunities to be able to deliver those experiences and allow people to have unique insights or the flavor of the drive based on other drivers or based on the road conditions that they identify.
These are consumer cars, and you have to worry about privacy. So the data that you're collecting, you have to make sure that it's really, really obvious what it's for. You're collecting only the minimum needed in order to train the algorithms that will, in the end, improve the user experience.
The amount of data that we use for each customer is based on how the customer wants us to use it. If somebody's in an accident and we have the GPS location, and if a customer wants us to do this, we'll send a beacon of help to the local 911 responder and we'll get the helper there. We can look at your driving patterns as you go into a parking structure, and we can tell by how hard you're accelerating and braking and how much you're turning. We've now figured out that you're on the third level in the northeast corner, and when you get out of the car, we'll pop up a diagram onto your phone to say, here's where you're parked. That's a nice little service, but we need your data to figure that out, and a customer can opt into those services.
Privacy is a major design consideration in the way we define things in our software stack.
It doesn't have to be specific data to your use. It can be anonymized, so to speak.
I think safety in the context of software is a very definable thing. There are standards out there. It's called functional safety, ISO 26262, ASIL D. That means your software has been developed and has been tested and has been certified for mission-critical applications such as steering, braking, and acceleration.
The ASIL requirements, for failures are so low because safety is so paramount that you make it work in a car that can operate in all weather conditions and all road conditions. It's going to be the compute platform for the future.
The hope is in the end, right, like that you're providing, that we are providing, for example, that one unified system that is able to grow and evolve to, whatever needs that anybody has in a car.
95 to 96% of the accidents happen because of distracted driving. So safer cars so that 1.2 million people can live every year and go back to their families. I think that for me is the biggest benefit.
It was really from day one about how do we get vehicles to drive on the public roads. And this was a really novel idea. Maybe a decade before, there'd been some cool work out of DOT and Carnegie Mellon in this with some buses and some cars, but we wanted to try and do an order of magnitude more driving than anyone had done before. Driving down Highway 1 from San Francisco to LA, driving around Lake Tahoe, right? Places where we would be able to understand the breadth of the problem, kind of get the first pass prototype solution for it and showcase that we could actually do these, take these driving actions, deal with real traffic, real people, and real scenarios.
The human experience gives you a great intuition of what are the places that you should be probing more, and what are the things that you should be worrying about. If you are training all of the agents that go into this world, and if you are making a really giant world that is, seeded from the real world, for example, at some point you can almost imagine, right, like you can run this and allow it to find issues that you didn't think about before.
With the release of AI machine learning, we're able to break through barriers that we couldn't break through with a traditional way. A rule-based system just had its limitations.
We sort of moved from very, very specific, very hard-coded, very restricted things, right? You can only do autonomy when in this condition and only in this certain way. And moving towards these much more powerful, much more generalized, elegant solutions that are able to understand what is going on and make these decisions that are sort of emergent.
Every OEM has petabytes of data that they've captured from vehicles to create the perception algorithms that create that artificial intelligent capability to know that that's a vehicle and it's exactly 140 feet away and I'm approaching it at this rate. And so at a certain point, I'm going to create a function to do something. I'm going to hit the brakes or make a maneuver around it.
As AVs are driving, we are gathering what happens in the future. And so you can use this data so easily to train really complex models. I don't know if you've seen this video of an AV that stops behind a truck that has a traffic light on its flatbed. And so maybe you've never seen this situation, but you know what's going on. And the AV, right, might get confused and think this is a light that it has to react to. And that's what we want the algorithms to generalize to as well, right? Like to not have to write all of these specific things, but to understand and synthesize from their corpus of knowledge, this is the context and this is what I need to do.
People ask me this all the time. When do you think autonomous vehicles can be real? They're real today. And in fact, they're probably better than the average driver in many situations.
I think commercial need will drive it more than anything else. If I look at one thing to drive this, it's a commercial need. I mean, if you look at truckers, we have a shortage of truckers, and it's only getting worse. So seeing trucks platooning between cities, I think that's a very near-term reality.
In general, when something becomes in the best interest of a company, the companies find a way to work together.
So the challenge is not getting data to the cloud. That's not a challenge. That's very doable. The cars will have 5G. But when you start to think about smart cities and how is a car going to interact with a smart city, then you start to realize if every car is talking a different language with their data, this is going to be a problem.
I think this will be one of those situations that to eventually truly have level 4, level 5 autonomous vehicles operating in a safe manner amongst we human drivers, I think there is going to need to be that level of collaboration and data sharing. And I think the companies get it. I think there's going to be a way to share what's necessary and no more in a safe, anonymized, firewalled way that gives you what you need to make this kind of utopian vision come true. At the same time, not give away the crown jewels for the individual companies.
Evolution into a software-defined vehicle is a partnership between the mobility domain expertise and the tech companies.
The tech companies thought that the auto industry was very slow-moving and conservative, and the auto companies thought that the tech companies were very fast and loose. But over the last 5 years, you've begun to see a convergence, a greater appreciation of the benefits that each player provides, and you're seeing a lot more collaboration.
That is the paradigm shift in the industry happening right now with software-defined vehicles, because in order to change this, you really need to have to change it not only from a architecture, technical architecture, but also how you are working together with suppliers and partners.
If you think about, just your smartphone in your pocket, when they first came out, there was very few apps. And then when they opened up the third, then you get this creativity pool. To me, this is where creative people will create really things that you can't even think of.
I think one of the challenges in extracting data from the vehicle is there's no standardized way to do it. If there's no normalized way to get data off of a vehicle, how do you create an ecosystem?
We all have to play together here to provide something of great value. Google creates Android, open source software, they control the architecture, the Play Store, things like that. But the ideas or the content comes from anybody in the world.
We've got a major transformation that's happening right now. We're being pulled into the vehicle. We're happy to go there and excited to see how the industry transforms.
I think our partnership with NVIDIA is a perfect example. It's a tech giant, it's a huge company, and they're working and acting also in very different fields, but they're also working with other OEMs.
There is so much knowledge that the automotive industry has. You cannot expect that maybe startups or people in software are going to be able to just catch on to all of it right away. And on the other side, right, like everything that we've learned has also been learned over decades almost.
And that's why we are hiring a lot of tech talent into our company, because we have lots of automotive domain expertise. And they can also help us drive that customer-centric, frequent feature update, because that's what the tech industry is used to.
I'd say it's a great time to be a software engineer. Now, every car company needs software talent as well.
There are not enough software developers for everybody wanting to do software. COVID has made it tougher. If you wanted to go to Google or NVIDIA or Qualcomm, you're going to San Diego or you're going to Santa Clara or you're going to Mountain View. Not anymore.
I think when you're trying to attract great people to come work somewhere, you need a mission that they're excited about. You need to be doing something worthwhile. You need a group of people and culture that's a place where you want to be, where you can spend time, where you're excited about the folks you work with, where you get energy from them. And then you need to pay them enough that they're not embarrassed, right? But I think if you have the first two, that's really the core of it.
The talent needed to be in this future of automobility, I think, is different than what it was when I joined the auto industry in 1969. Something else that's very different. It's going to be very unusual for someone to stay with the same company like I did from 1969 to 2009.
Back then, software engineers didn't go work for GM or Ford or Chrysler. Some of the best software engineers in the world now come work for us. It's very different in terms of seeing people coming out of school who want to come work on automobiles, which I think is fantastic, right? Because this is right now the intersection of one of the coolest things on earth, right? You have this traditional 100-year-old business with the best and the newest and the brightest of Silicon Valley. It's kind of one of the coolest places to work.
The only people who know what's possible here are the ones who are working on the cutting edge of knowledge.
The skill sets that we are trying to hire and expand our resources is not just automotive traditional OEMs or tier ones. Right now, our pool of competitors is including Apple's and Google's. But at the end of the day, regardless of the skill sets you have, what you want to achieve with them and in which domain, usually that determines where people want to make the biggest difference.
Technologists like me, who have a great business acumen, are being asked to play roles not just in IT, but to take a front seat in shaping the trends.
Very few people in life really get that opportunity to sign up and go do something that's going to have a big impact in the world.
If you've got this great vision and you can really articulate it and you can say why it is that it matters, and then you can figure out your place in it, and if you can allow other people to do the same thing, then you can achieve great things together.
I think it's really being attracted to an industry which is under disruption. Every technology, every business model will end up being disrupted.
There really are no long-standing incumbents. Like, it's almost a clean sheet of paper. If you imagine it, you can go create it. The rules around how these vehicles work haven't been written in stone yet. So for people who are creative and who want to go help shape the future, like, this is where you want to be.
What is going to attract someone to want to spend their whole career with the company? I think it's the opportunity to have an impact. It's the sense that because what I do every day, I'm leaving my fingerprints behind on the world.
With technology now, it's front and center in the car, and it moved from back end to front and center. This is the most fascinating transformation that I have seen in my life.